Hello everyone. We continue the lesson of the inverse trigonometry. Okay. So today we're gonna talk about the compositions of functions. Composi compositions of functions. You used to learn previous years, right? When grade 9 or 10, I believe that. So, but now we're gonna talk about the inverse and see this one on the whiteboard. Before, right, you should get recognize about this formula, okay? The inverse function, if we have function, I move this one up. If we have, say, function of inverse function f of x will equal to x, right? It's kind of like this is a function and this is an inverse cut, so you left x here. And at the same time, if you have inverse function of function f of x, then this one also equal to x. That's the one you learned before, okay? But then see this property there. Right now, talk about the inverse properties of trigonometric function. We see this table first, okay? And we go to some example. This table you have to keep in mind anyway, okay? Kind of property or definition you have to keep in mind. Again, come to here, arc sine, right? Remember when we have arc sine of arc sine x, right? The restriction is here, correct? Domain have to be from -1 to 1 and y range from negative pi over 2 to pi over 2. Okay, this arc sine x, the property arc sine x, right? And then at the same time, if we write it down, become sine arc sine x here. Sine arc sine x, I write my sine here, okay? Sine arc sine, right? Arc sine. We can write it down in this way also, correct? Arc sine x will equal to x. See that? So this is the same property of this one, correct? The previous years you learn. Okay, so this is equal to x. So in this inside is the x value, is the number. Okay. At the same time, if you have arc sine sine y will equal to y. This is an inverse of function, so become y. Okay, this is like a cut. You can see simplified in that way. Okay, so in this case, this one is mean this one, right? And this one mean this one, correct? Means this one. Okay, you can apply for that as long as in this condition, don't forget, in this condition, domain and range, every time, don't forget, must be in there, must stop in this condition. Now you see next one. If we have, this is a arc cosine. This one is a property of arc cosine, remember? This is a arc cosine x. Okay, again, restriction, same with the arc sine, right? Same with the arc sine. This one same with the arc sine. But this one different now. For the range, have to be between what? Close, right? 0 to pi. Okay, so this one means drop in what? First quadrant and second quadrant, but for sine is what? First quadrant and fourth quadrant, correct? And then this one, last one, it talk about arctan. See this one, arctan. The last one here is arctan x. Okay, arctan x. So the property of this one, the restriction is this one, don't forget. The range is same with, not exact, but similar to sine, arc sine x. But only this one include, right? This one have equal sign, but this one open, right? For tan, arctan is open. But x, the domain x is what? Real number. That means negative infinity to infinity. Again, this is very important. Keep in mind for that. Okay, one like this one, you like this one, tan arctan, you can write in this way, right? Tan arc tan x, then equal to x is a simplified cut, right? And then at the same time, if you have arc tan y equal to y, simplify is equal to y. Okay. Then sine the same thing, this one, right? The blue color here. I did not explain here. So you see this, if we have cosine arc cosine x, cosine arc cosine x will equal to x. And for the, if this one is this one is the whole thing is a y, right? So then this one gonna be, if this condition, we can write in this way, right? Arc cosine of cosine y will equal to y. Okay, see the color what I wrote. Okay, so then this need to keep in mind. And y have to restriction, y have to restrict about x domain and range. Last lesson we already say, if you don't restrict it, final this inverse function, it will not longer to be the function anymore, gonna be relation. Okay, so we have to restrict it. Now we see example. See example this one. Everyone see this one. Keep in mind. This one they say as you keep in mind. See that's, I will get example from here. So easy way to, and then you can review one more time. You see in this condition. Okay, this condition, or we just do one at a time here. No matter arc sine x or arc cosine or arc tan x. Okay, they have something have to keep in mind here. Okay, for example, like this one, arc sine 32. So this one, if we write down, become arc sine, right? Arc sine 3 pi over 2, that means 270 degrees, right? So normally, if you see this one, you're gonna say cut, and then equal to 3 over 2 pi, right? According the definition here, like this one, right? This is the same, right? From here to here. But you see this 3 pi over 2 or 3 over pi, 3 pi over 2, this one is a 270 degree. You see that our bar, right? The restriction of arc size what have to be from negative pi over 2, right? If you plot sine, right? You plot the inverse arc in a inverse sine function. The restriction have to be what? Pi, right? Over 2, and this one minus pi over 2, correct? So this is the restriction right here for range. And one, but for x should be negative 1 and 1, of course. Okay, so then if you have the value of this one, it's our bound, right? It's go out from the restriction have to be quadrant 1 and quadrant 2, correct? Sorry, 1 and 4. But 270 degrees gone. It means it's our bound. So this one, if you answer equal to 3 pi over 2, it's wrong, right? So you have to use like a, in this case, it is wrong. We don't have. But next, you consider they have any coterminal angle or not. But this one doesn't have, right? So this one, just say this one is not equal. In other words, the property of arc sine y to y is not valid for y. See that? Because the outside the interval, that's what I'm just explaining. Okay, so in this case, not, okay, not equal. Okay, so even though they have coterminal, this one minus pi over 2 here, so they're not equal either, right? Because this one not equal. Okay, so now we go next example, and you take a look, review one more time for each condition. You see this example, they try to explain, we just talk about the property of the inverse. The property of the inverse of the trigonometric function, trigonometric functions, okay? Then see this, see question A. This one, right, we can write it down, become 10 arctan, right? And negative 5. Okay, so this one you can see from the property of inverse trigonometry. If you go according the property we just talked in the table there, you can cut, and then you say equal to negative 5. So this case is work, you know, this is okay, correct. Why? Remember the property of arctan, arctan inverse tan function is what? Domain is what? Real number, right? Domain is a real number, correct? And the y range is what? Open minus pi over 2, correct? And this pi over 2. Open, okay, not include. If arc side, yes, is close, include, but this one doesn't exclude. This one exclude for arctan function, arctan x. So this one, okay, you know, negative. Right now, this one is inside here is a x already. So this one is a number, right? So negative 5, so okay, correct. So in this case, you see x drop in negative infinity to negative infinity to plus infinity. So okay, because they drop in this length, this domain. Okay, the arctan, remember when arctan inverse tangent function, the graph is like this. You remember if I draw, do it really fast here. If we plot graph, even recall, no? Like this way, and they have asymptote like this. Remember asymptote here. Okay, and then the graph is come somehow like this. Approach, this one approach should be curved like this, and then approach to here. This approach to here. Okay, like this one. This one we approach to this, and this one gonna approach to this curve to asymptote. Okay, approach just closer. Okay, and then this one is what? Pi over 2, and this negative pi over 2. That's why here is a asymptote line. See, that's why open here, everyone recall that. Okay, so in this case, x is what? X can be infinite both, right? To negative and positive. So x, this one equal to negative 5, then should be somewhere here, right? So it's okay, it's work. So this one okay for this question A. You can use the property of the inverse property of trigonometric functions. Then you just use the idea, say, okay, this cut simplify equal to negative 5. Okay, now we see question B, right? We go question B, see. Question B now here. This one we can write it down, become arc side of this one, right? We can write arc side. And then side 5 over 3 pi, correct? Then again, if you go according the property of inverse, property of inverse properties of trigonometric function, you're gonna cut like this, and you're gonna answer say equal to 5 over 3 pi, correct? But again, this one really important. You know why? Because 5 3 over 5 over 3 pi equal to what? 3 times 180 over 3, right? So become 18. So become 300 degrees. Okay, that means 5 over 3 pi equal to 300 degrees. Again, this one you see the definition of arc sine or inverse sine function. 300 is kind of our bound again, right? Because for restriction of sine is what arc sine is close, right? For y, it pi over 2, negative pi over 2 to pi over 2, right? Close, close. And then domain is what? Domain should be close 1 and negative 1 and 1. Okay, so now you see this one and arc sine have to be quadrant 1 and 4, correct? If we plot graph. If we plot graph here, should be quadrant 1 and 4 for arc sine or inverse sine function. So when you have 300, it's kind of our bound, right? This one pi over 2 again, and this one negative pi over 2. So the 300 go out our bound already, right? So now you have to find they have any coterminal or not, right? have any coterminal. So if we, for example, with 300 degree, right? If we rotate according anti-clockwise here, because they're plus, right? So we rotate in this way. So from there to here is a 300 degree, right? Everyone. So you have like this. So then this one is called coterminal. Okay. So this is a 300, right? So coterminal, this one is 60, correct? 60 degree. Then we have this one, then we can use this one because 60 degree here, 60 degrees drop in the fourth quadrant. So instead, we're going to answer this question, say equal to 5 over 3 pi. If you answer this one wrong, right? By use the property of limit, by cut, simplify this one and equal to this. You have to convert this one to the condition of the arc sine x, right? Or inverse sine function. You have to by using the coterminal. So we use 60, right? 60 degrees or pi over equal to what? Pi over 3, right? Equal to 60 degrees. But then this one you cannot rotate like this. Then now you have to rotate according clockwise. So now this one have to be what? Negative, right? A1. Because we need this one, right? In fourth quadrant. If you do this one again, it's no use. So we have to have negative pi over 3. So in this case, right, from here, for question B, right now we do question B here, okay? So from this one, you can write down, say, arc sine, right? Arc sine of sine 5 over 3 pi will equal to arc sine of sine negative pi over 3. So we can write big bracket here and this small bracket here, okay? And then big bracket here. Then you can answer, now you can use the property of sine now, right? Because negative pi over 3 is okay, it's drop in between this one, right? You see that? Negative pi over 3 drop in this one, right? The definition of arc sine x. So then it works. So then you can use property of the inverse property of trigonometric function. So this one cut, simplify. So you left negative pi over 3. Everyone get it now? Okay, this how to show the work for question B, okay? And then you will understand also. Try to explain as much you can first. Until later on, if you understand, maybe some step you don't need, right? But this step you should write down, correct? And use a picture, that's really helpful. And put the picture correctly also, and label it every time when you work on. Okay, so now we come to question C. What color we're gonna use? Blue. Okay, now C, question C here. Cosine, right? Question C can write down become cosine, arc cosine. I like that, just follow what they say. Arc cosine pi over this one, cosine, arc cosine pi. This one, if you do property this one, but you consider this one first, right? Consider inside first, like every time we consider inside here, like a question B, we see this one, what is about. They drop in any condition or not, right? And also, even though this one pi is kind of will drop in the cosine, but arc cosine pi is the undivided. So this one you can't find anything, right? Then this one no solution, correct? So this one is the undivided. So this one no answer. Okay. Because the domain of this inverse sine function is what? -1 and 1. Don't forget right here. Okay. Because this one is the x now, right? The whole thing is the domain. Okay, and then this one our bound. Okay, so the example talk about before by using the property of the inverse properties of trigonometric function, how to use it that, right? Some you can cancel and quote it right away, like question A. But some you have to every time have to consider inside. See, they drop in the condition or not. See domain and range, that's all. Okay, now we go next one. We go next example here. Find the exact value. Question A, tan arc cosine 2/3. Okay, so in this case, how to do arc, find this value, tan arc cosine 2/3. First of all, you always work from inside, right? See from inside here, arc cosine 2/3. So in this case, it doesn't come for like a tan arc, tan or cosine arc cosine anymore, like a previous example, right? Right now they have like a different thing, tan and cosine mixed around. So in this case, we work inside first, correct? We work inside, so we just say if we let you, or just say let this one, they can write down become this one, right? Tan arc cosine 2/3 also, correct? I can write in this way, right? Not nice. So arc cos is a 1 bracket 2/3. Okay, so I do this one. Let u equal to cosine. I mean arc cosine 2/3. I want to convert to be the simple form, right? So it's easy to see. Try to write in the simple or normal pattern you get used to. So I let inside here arc cosine 2/3 equal to u. So from this one, we're gonna have cosine u is what? Equal to 2/3, right? This before, like we find the angle, like a cosine x equal to 2/3 like this, and then you find for x, right? This is the same idea. Like when you have like this, right? Cosine x equal to 2/3, for example, you want to find x how many degree or radians, correct? So you like x equal to arc cosine 2/3 like this, and then you use calculator, remember? That's the same idea. Okay, now I let this one, I need more space. Everyone get it? So I let here now. So from this one, when we have this one, right? So you put the, see cosine here is a plus sign, right? 2/3 is a plus sign. So, and the arc cosine, the property of arc cosine is what? How from where, right, to where for the range? 0, right? Close 0 to pi, correct? So that means is what? Quadrant 1 and 2, right? So in this case, you draw, but cosine is a plus. So quadrant 1 and 2, cosine plus is what? Quadrant 1. So we put graph in the quadrant 1. We put graph in the quadrant 1. Okay, maybe I draw here more space here. Make it bigger. So quadrant 1, so you draw one right triangle, right? Draw one right triangle. And draw. So in the handout they have also, but now I explain one more time so you can read it later. But see how we get the picture. Okay, now try to explain. So now this is a cosine u. Right now it's a u, right? And this u equal to what? Arc cosine 2/3. You can write down here. Write it down every time, so easy to find the angle later. So this means this angle, okay? The whole angle here. U. So then you say cosine u, right? U is what? Add over hypotenuse. So 2/3 right here, correct? Add hypotenuse. Okay. So then this side gonna be what? 3/2, correct? It's gonna be 3/2 minus 2/2 square root. Come out 9 minus 4, so we have square root 5 here. This is a Pythagoras theory, right? Okay, so when you have this one, have this triangle, now you can start to find the, or now this one I do, okay, right now we do question A, okay, everyone, question A here. So after this one, what we gonna have? We want to find tan of arc cosine. So after this one, you can write down 10 and write down here. Because this this one's a u, right? So I can write 10u, correct? Now you read from the picture here, the figure here, 10u is what? 10u, 10 is a op over adjacent. So you're gonna have 5 over 2. Okay, so now this is the answer now. Then you replace rewrite it. So become 10, u is what? U is mean this one, right? So become arc cosine 2 over 3 equal to root 5 over 2. So this is the answer. Okay, it's easy now, right, everyone? Now we see question B, how to do. We go question B. B, right? Do the same way, right? Do again, you see inside now, arc side. Arc side, you see inside here, the bracket here is a x, right? The value of x is a number already. Now we do question B, okay? This negative 5 or 305 is a number already, it's a x. So we can rewrite it down in this one, correct? Cosine arc side, negative 3 over 5, and then close, right? I mean, you can write this kind of bracket, okay? So now we work from here again, get inside here, the whole thing arc side. This one should be arc side, sorry. Should be arc side of negative 3 over 5, that equal to u. So right now we do question B, okay? So let u equal to arc side negative 3 over 5. Then sine u become one. Let u, we start. Let this question be said, let u equal to arc sine negative 3 over 5. So we have sine u equal to negative 3 over 5. Okay, now because restriction of arc sine is a quadrant 1 and 4, correct? Because have to be from negative pi over 2 to pi over 2. So quadrant 1 and 4. And quadrant the sine, which is 1 and 4, which one is a negative? Quadrant 4, right? So we plot on the quadrant 4. Okay, so we plot on the quadrant 4. So I let this one, I need more space. Bring up here. So this is gonna be here. And sine, this is a u now, right? Okay, this angle equal to arc sine negative 3 over 5. And this the whole thing angle represent these two names is the same, okay? So now you read sine u, this is a u, like a theta, okay? Sine u is what? Op over hypotenuse. So op this 3 over hypotenuse is 5. And because this come down y is a negative, so you have to line negative here. Then from this one to here, the x-axis is gonna be 5 square minus 3 power 2, the whole thing, okay, and then square root. So come out equal to 4. Okay, one. So then this, we got the right triangle now. Then you can read this value now. Question B, you can read this one now. So we can have cosine arc sine negative 3 over 5 equal to what? Because this arc sine negative 3 over 5 means u, correct? Right? Same thing, right? So you just list cosine u from here. Cosine u is what? Add over hypotenuse, right? So you have 4 over 5, that's all, finish. So you get the answer, right? Continue the example. Write is the following as an algebraic expression in X. Question A. Question A is what? A here. Sine arc cosine 3x. They have restriction here, domain. So if we rewrite this one become sine, if we can write in this pattern, correct? Sine arc cosine 3x. Okay, so how to do? Same thing, right? You can get inside first because right now they did not come with sine or tan or cosine, arc cosine. So right now this sine and arc cosine. So just let inside again, similar like a previous example we just finished. Make this one equal to u, it's okay. So from here you just say let u equal to arc cosine 3x, right? So from here we have cosine u equal to 3x. Again, cosine, the condition of the arc cosine is what? 0 to pi, right? The condition is 0 to pi, so it should be quadrant 1 and 2, okay? And which one cosine plus? Because it's a 3x is a plus sign. So it should be quadrant 1, right? Because quadrant 2 is a negative cosine. So we draw what graph? We use the first quadrant. Okay, we draw the first quadrant. Now this one is a u now. Okay, this angle equal to arc cosine negative 3x. This the whole thing's angle represent. Okay, so now you lead this one, lead cosine u. This is a u, right? The theta. So u is adjacent over hypotenuse. So we have adjacent here over hypotenuse 1. So this one, this side, this length, this, okay, gonna be what? 1, right? 1 square, so 1 minus 3x square, right? 3x square become 9x square, correct? And square root. So this one represent, okay, the value. So now you lead now, gonna be what? After this one, because u is what? You can represent this one back. U equal to arc cosine 3x, so you lay it back. This one, right? Become, replace it back, 3x, arc cosine 3x. Then equal, because it's a u, right? So then you can lead now, lead cosine. Oh no, this is the one side, sorry, I have to change, I'm wrong here. I have to change this one. Should like that because question needs sine, not cosine. So this one sine of arc cosine 3x. And arc cosine 3x is a u. So you lead sine, correct? Then now from here you lead sine u. Sine u from picture here. Sine u, sine is what? Of over hypotenuse. So you have square root 1 minus 9x squared over 1, right? So that means square root 1 minus x squared. This is the final answer. Okay. And then why the restriction here? Tell me the question. Tell me why the question restriction right here. I like the pink color. Why they have to restrict here? Why? Everyone can answer. Because if you don't restrict, for this one anyway, we have restriction x what should be -1 from -1 to 1, right? But now they restrict this one because you see inside here. If you replace the value of x, if you don't restrict, right? When x go out of bound, even though you get the 1, right? Even it's drop in the restriction of x or sine or cosine. This one gonna be negative, right? Under root. So they have to gonna be negative, so become undefined. So we have to restrict the domain. Then we just can get the value of inverse of this function. Okay, everyone get? Because if you replace x equal to 1, this one become 1 minus 9, right? So equal to -9. Square root become square root -9. This is undefined, correct? So that's why, that's the reason. That's the reason why we have to restrict the domain. Now go to question B. Question B say cotangent. Cotangent, then you see, but inside they give you the same, right? From question A, arc cosine 3x, this is the same, right? So you see question B very easy now. Because we have this graph, we can use at the same time, right? So in question B, you just read what? If we want to read this one, cotangent arc cosine, not sine. So become cotangent arc cosine 3x. Okay, so this r cosine 3x is equal to u, right? Here, A1, this one, right? This angle, this equal to u. So you can actually you just write down become like this, right? You can replace this one become u, so easy to see either one, this one from this one, they're equal. So you leave cotangent u. Okay, if you leave cotangent u, you just leave tan, correct? You leave tangent first. If you leave tangent, tangent u is what? Tan x, tan u. Tan is what? Op over adjacent. So you have 1 minus x squared over 3x, right? Then cotangent reciprocal. So this one gonna be 3x over square root 1 minus x squared. That's it. And then this is the answer. This is the final answer. Okay, same thing. And then they restrict the domain, the same idea. Okay, because if you don't restrict x here, then when x, like even the drop in the condition of cosine, inverse cosine, but couldn't get it because this one gonna be negative under root, so it's undefined. That's the reason why this question they restrict the domain. Okay, I think that's all for inverse trigonometry function, and the rest you're gonna practice question. After this, we're gonna have combination question, which is harder than this one. Okay. Okay, now I think that's all for today. See you next class. Bye bye.